So before moving on further into the section, I just want to warn you that this method that I presented over here only works if you're doing a proof by counterexample. So this method only works to disprove a certain identity. So if they're telling you to prove something, this would not be the method to do this. You would do this method if you are convinced that the property you're trying to show is false, or if you're testing and you think it's going to be false. Okay, so be careful. This would not consist of a proof. Okay. And since they told me I can make A, B, C any sets, I decided to make A, B, C, B these following sets. And I turned out that, you know, like this property does not hold here. Okay. Now, if you know that a certain property is true, then you can kind of use it to generate bigger and bigger properties. And that's what we're going to be explaining in the next couple of sentences over here. But these are the methods I was talking about, the optimistic approach and the pessimistic approach. Okay. So let's go ahead and take a look at example 2. And in this particular example, it may be helpful for you to have the table from theorem 6.2.2 in front of you as we're looking at this problem. So I'll give you a second to find theorem 6.2.2 with all the identities and take a look at it while we're working on this problem. Okay, so what I'm gonna be working on is an algebraic proof right here. So I'm gonna start the same way as usual, let A, B, C be any sets. And what I'm gonna do next is build a chain of equalities and prove that either the left-hand side is equal to the right-hand side or the right-hand side is equal to the left-hand side. So it does not matter which one you start with as long as you get to the other side somehow, okay? Now, I'm gonna start with the left-hand side. So I'm gonna write down left-hand side equal to, and I'm gonna copy it, A union B, minus C. And I'm going to try to break it down using the properties from the theorem 6.2.2. I'm going to try to see what I could do. The very first thing you should notice about the table is that there are a lot of properties with union and intersection and only one property that has a minus sign. So typically what that means is if you see a minus sign in the problem, you want to get rid of it right away. Why? Well, if you get rid of it, then you will be able to use the other 11 properties in the table. Okay, so I'm going to do that right here as well. So I'm going to try to change that minus sign. And according to the table, a minus C can be replaced with, this is set difference. It can be replaced with an intersection and then C complement. Okay, so this is true by property number 12 called set difference. Now, since I was able to rewrite the problem, I'm going to try to use another property that I can see from the table. There are 11 with unions and intersections and so on. But I will go ahead and choose property number 1 right now to rewrite this expression. I would like to have the C complement first intersected with a union B. Okay, this is in preparation to what I want to do later on afterwards. This is by 1, which is commutative property. Okay, so I wanted to do that because next what I'm going to do is distribute the C complement to the A and then distribute the C complement to the B. And keep in mind there was an intersection on the outside. That's why there's an intersection between A and C complement and then B and C complement. Now, what's the middle sign going to be? The middle sign is going to be the union, the one that was inside the parentheses, basically. Okay, so this is true because of the distributive property. Okay, so I'm almost done. All I want to do next is reuse the commutative property to swap the A and C complement. I would like to have the A first and then the C complement afterwards. And similarly, I want to swap the B and the C complement. I can do that by the commutative law again. And finally, I'm going to rewrite each one of these intersection and complement as a minus. Okay, this is again the set difference. So A minus C, union B minus C. This is again by rule number 12, set difference. But at this point, I would like you to notice that the thing that we just wrote is exactly the right-hand side. So the property is true. So the theorem actually holds. Therefore, we are finished. Therefore, we are done.